Alright, today we're going to look at 9.4 part 2, which is on ellipses. So this is the second conic section. Remember, the way that you can get this section is if you have a cone and you slice it diagonally. But when you slice it diagonally, you got to make sure you go through both sides of the cone and you don't come out the bottom. Okay? If you slice it through the side and then you turn it and look at the shape, you'll have an ellipse. All right, so let's start with the definition. So the definition of ellipse, first of all, that is a two-dimensional shape. So it's a collection of points in the plane such that the sum of the distances to two fixed points is a constant. So it's not that we're measuring the distance to one place and then the distance to another place like yesterday and saying that those are equal. We're saying that if we measure the distance to one fixed point and then another fixed point and add them together, it comes out the same. Okay? And I'm going to show you an example of that in the same program I used yesterday. So I can drag a point and you'll see it. Show you.
Just because of like Why's law, like yeah, so it's always gonna somehow be equal to.
So here's the two special points that I'm talking about, B and C. Okay, those are the fixed points. And the distances that I'm going to measure are segment EB and segment EC. Okay, I'm going to measure those two distances. As I drag point E around the ellipse, this number and that number are going to change. Okay. But the sum of those two numbers is always going to be, in this particular ellipse, 17.3. Okay, that just happens to be the number based on the size of the ellipse that I drew. Okay, so let me just drag point B. I'm sorry, point E. So as I drag that around, okay, those two numbers are changing. But no matter where I drag it, if you add 5.68 and 11.62, that will add up to 17.3. Any question on that? And that's how you draw an ellipse. If you actually want to draw one with like a string and a pencil, well, to do a circle, all you need is like put a push pin in like a board, take a piece of string, attach it to the push pin, pull it tight, and then draw, and you'll get a circle. With an ellipse, if you take a loop of string, put two push pins in a board, put that loop of string around the two push pins, pull the loop of string tight, and draw, that's how you get an ellipse. The closer you put the two pins together, the shape starts to turn into a circle. When the two foci, that's what these are called, plural of focus, when the two foci become one, there's your circle. The further apart the two foci, the more elongated the ellipse becomes. Any question on that? There's really two different orientations for an ellipse. Okay, with a parabola there was 4, opening up, down, left, or right. With an ellipse there's 2. Horizontal, that's what this one would be, and vertical. So we're going to go through a lot of the vocabulary stuff up front. There's a lot of new terms. There are some terms that are the same as yesterday, but there's also a lot of new ones. Okay, those two fixed points, think of those as like push pins that you put a loop of string around to draw. Those are called the foci. So in this picture, B and C are the foci. I usually call them like F1, F2. It doesn't matter which one is which. All right, so start with this right here. That is summarizing what we just wrote in words about an ellipse. D stands for distance. If you measure the distance from this point to the first focus, and from the same point to the second focus, and add the two distances together, you always get a constant. In my ellipse, it was 17.3. Understand, it's not always 17.3. It depends on the size of your ellipse. But it's a constant. Okay, I'm going to talk about some other terms up here in a second. I'll talk about them as we scroll down. Okay. You know what? I'll kind of fill them in as we go too. So if you draw a line going through the foci, okay, that is called the focal axis. Okay, I'll do that in blue. Okay, that's the focal axis. So that's a new term. We didn't have anything like that with parabolas. Okay, so that's the focal axis. If you draw a chord, okay, remember a chord, like when you draw a circle, it's like a line segment. Okay, so that's basically what it is. So if you draw a chord with the endpoints on the ellipse running on the focal axis, okay, like this. Go from here to here, and let's connect that line segment. Okay, again, it's really called a chord in an ellipse. That line segment that I just drew in green, that is called the major axis. It's the part of the focal axis that's inside the ellipse. The focal axis goes on forever. Okay? The major axis, another way to think of it, it's the width of the ellipse, the long way. Okay? We can think of it maybe as the length of the ellipse. And put it down here. So that's the major axis. Okay, if you draw the midpoint between the two foci, okay, that is called the center of the ellipse. So the midpoint of the segment that joins the foci. You could also think of it as the midpoint of the segment that joins the vertices. That's really the same thing. Okay, right there, that's the center. So that is a new thing that when we describe ellipses, you have to tell me that now. Right? You don't have to tell me about a directrix anymore because the directrix doesn't exist. But you do have to tell me about the center. So it's the midpoint of the line segment that connects the foci, midpoint of the line segment that connects the vertices. Same thing. So I described to you the chord in the ellipse that runs the long way. That's called the major axis. The chord that runs the short way, that's called the minor axis. Okay, and I'll go back up and draw that in. Okay, but that's called the minor axis. Let's see, what color can I use? Let's do. I got bright green. Okay, so that chord that I just drew right there, that's the minor axis. So that's something that we'll usually describe when we describe an ellipse. I'm going to ask you, which way does the major axis go? Horizontal or vertical? And then obviously the minor axis is perpendicular to the major. Those are perpendicular. Minor axis. All right, I mentioned this. I didn't really define it yet, though, but the 2 points where the major axis basically touches the ellipse, those are called the vertices. So the 2 points in red, V1 and V2. That's where the major axis would touch the ends of the ellipse. You could also think of it as where the focal axis crosses the ellipse. That's V1 and V2. And I think that's most of the important vocabulary around ellipses. So foci, vertices, focal axis, which I don't refer to focal axis a lot. Major and minor axis, I refer to those a lot. Center. Okay, and where do you notice the foci are in relation to the vertices?
Same axis.
They're on the same axis. What else do you notice about them? Positionally, yeah?
They're closer to the center.
They're closer to the center. When you draw an ellipse, the foci are inside of the vertices. When we do a hyperbola tomorrow, that's going to switch. Basically, a hyperbola is everything about an ellipse backwards. It's pretty much what a hyperbola is. Okay. So for that reason, it can make ellipses and hyperbolas a little confusing because they're almost identical, except everything is like reversed. So we gotta be careful. Right, but keep that in mind. The foci are inside of the vertices. Always. Okay. Any questions on any of those definitions? It's all of them right there. Okay. So let's talk about the equation for an ellipse. When we did parabolas yesterday, one variable had this exponent and the other variable had this exponent. Does anybody remember what were the exponents on our variables? Yeah?
Y was squared and x was squared?
No.
Oh, wait, no. What do you mean by the...
Well, that's what I want to know pretty much. But that y. So he said y was squared and x was squared yesterday.
So like the equation?
Yeah, in an equation.
Oh, so like y squared equals 4ax.
So one was squared and one wasn't.
Yeah.
Yeah. So in that case, y was squared, x was to the first. Or x could be squared and y could be to the first. Well, the difference today, we're going to see both variables are squared. X squared, y squared. So that's a big difference from parabola. All right. As always, we're going to start out with the case where the ellipse is at the origin. And then after, we're going to shift it. You'll know when it's shifted because you're going to see an h and a k in the formula. Like a minus h and a minus k, just like yesterday. But for now, we're going to look at the case where it's at the origin. The foci are going to be c units to the left and to the right of the center. So that's what you want to understand about what c is. C is the distance from the center to the foci. Based on that reasoning, what do you think A is? Yep.
One foci? And one of them?
No, A doesn't have to do with the foci. C has to do with the foci, but A is...
Vertices?
What about it? If you wanted to describe it as like a distance.
I'm thinking like absolute value almost.
Well, A is always going to be a positive number because it's a distance.
So distance from center? Like
A is the distance of what from the center?
like the edge of the ellipse of the vertices.
The vertex, yeah. A is the distance from the center to the vertex. Left and right. The reason it's left and right in this case is because the major axis is horizontal. That means your ellipse is going to look like this. So foci is C units, left and right of the center. The vertices are A units, left and right of the center. Okay, a couple things about A and B. First of all, A always has to be bigger than B. That's just, in this formula, that's a rule with ellipses. A is bigger than B, and B is bigger than 0. So in other words, A and B are always positive, but A has to be bigger than B. Now, if you only know the A and the B, you need a way to figure out the C. Or if you only know the B and the C, you need a way to figure out the A. So there's a formula that gives you a connection between the A, the B, and the C. The formula is C squared equals A squared minus B squared. So we're going to use that in almost every problem. If we only know 2 out of 3 of the letters, we can figure out the third one. Yes?
Should we be able to identify, like, does this also apply to, like, rotating an ellipse? So we're just talking about the X and Y axis?
We're not going to rotate ellipses, no.
So it's only going to be the 2 things, either the X axis or the Y axis?
Yeah. We're only going to have 2 cases for ellipses. But yes, technically you can rotate an ellipse on any arbitrary angle you want.
But what we're going to learn this year is just the 2 axes.
Mm-hmm.
Okay.
Okay. And your formula is x squared over a squared plus y squared over b squared equals 1. That's the equation for an ellipse. It is important to always get it equal to 1. It can't be equal to any other number. All right, so it's a lot of information at first, but once we start to do it, it's going to be just like yesterday. I'm going to either give you an equation, you're going to tell me all about it, or I'll tell you all about it, and you give me the equation. All right, so if they want us to graph an ellipse, sometimes the intercepts are helpful, not always. Why might intercepts not be helpful when you're drawing an ellipse? Yeah?
When the center is not 0, 0, like it wouldn't be helpful.
Well, even for an ellipse that's off center, I mean the intercepts could still be helpful. You know, helpful things to find.
It could.
Anybody think why the ellipse might not be helpful at all? Yeah?
It's not in our equation for an ellipse, so it doesn't tell us anything.
What do you mean it's not in the equation? Yeah?
I'm thinking, like, maybe it could help with the size of the ellipse, like the distance of A, for when we're doing like the equation. So obviously, if you're off center for both of them, you're not going to find the exact A, but it should be like kind of related to the size, not positioning, because that positioning doesn't really matter. For all that, so I would guess it helps you with figuring out the size of the ellipse.
Well, yes, if you know the vertices, you can pretty much get the size of the ellipse because you have the, well, if you have the intercepts, it kind of helps you draw it. But my question is, where would they be unhelpful? Where would the intercepts wouldn't even help at all? Yeah?
When they're like, when they're not touching the axis.
Right. If you draw an ellipse like this, well, good luck with the intercepts. I mean, that's not going to do anything because it doesn't cross any axes. So sometimes it's helpful to know the intercepts, not always. So a couple of reminders just about what A, B, and C are. A is always the distance from the center to the vertex. Okay, so that's A. A is the distance from the center to the vertex. C was the distance from the center to the foci. I didn't tell you what B is yet. So A is from the center to the vertex. C is center to foci.
I guess what B is.
You can guess. It's not the easiest thing to guess though.
Like the width of the ellipse.
Yeah, it's basically the distance from the center to where the minor axis would cross the ellipse. So if you want kind of a visual on that, here's your center. That's A, the distance from the center to the vertex. B is the center to the minor axis. And C, well, remember, C is kind of an imaginary point. It's the foci. The foci isn't actually on the ellipse, it's in the ellipse. But C is the distance from the center to the focus, which would probably be like somewhere right there. But that's A and B. So we got to kind of think about things like if they told us in the problem, the length of the major axis is 10. If they tell you something like that, they've just told you A, because this is the major axis from there to there. So if they told you the length of the major axis was 10, how much would A be? 5. Yep. And what if they told you the length of the minor axis was 6? What's B? 3. So they can say things like that when you need to do an ellipse. They can also give you coordinates, and then you got to find the distance yourself. But any question on what A, B, or C represent?
Should we expect word problems with this unit for all the circle information?
No more or less than the kind you saw yesterday. Yeah. So there might be problems where word things like this. You have to figure it out.
No, I mean it's like the story thing or something like the height of the flag post versus relative to where you're standing, or the whole Boeing 747.
No.
They got okay.
All right. So find the equation of the ellipse. First thing we have to do, you don't really have to do it yet because you don't know the other kind of ellipse, but you need to figure out which equation it is. Just like in a parabola. Is this the one where it goes horizontal, or is this the one where it goes vertical? I want to go back for a second, look at the equation I just showed you, and then I'm going to skip ahead to the equation we're going to do. And I want to see if you can see the difference between a horizontal ellipse and a vertical ellipse. Okay, so here's the equation of a horizontal ellipse. X squared over a squared plus y squared over b squared equals 1. Let's go to the vertical. Does anyone see a difference? You don't have to write it all down because we're going to get there. Does anyone see a difference with what's in this box now? Yeah?
The A and the B are switched.
The A and the B are switched. So the way you can remember which way the ellipse opens is A is always the bigger number. Whichever letter has the A under it, that's the direction the ellipse will open. If the bigger number is under the Y, the ellipse is going to open in the Y direction. It's going to go up and down. If the bigger number is under the X, it's going to go in the X direction. Okay? That's how you tell the direction of an ellipse. All right, so let's look at this one. So let's graph it and see if we can start to figure out how the focus and the vertices are lining up. Are they horizontal or are they vertical? Okay, so center is 0, 0. Okay, where are my foci? What? Yep.
3, 0, 3, 0, and then negative 3, 0.
Yes. They didn't tell me the other one, but it has to be there. Okay. Foci always come in pairs. 3, 0, negative 3, 0. And where are my vertices?
Negative 4, 0, and 4, 0.
So negative 4, 0, 4, 0. So what kind of ellipse is this going to be? Horizontal or vertical?
Horizontal.
Horizontal. Everything's lining up horizontal. Okay, this isn't exact, but it's going to be something like that. I didn't space things too well. Okay, so we need the equation of an ellipse that is horizontal. Ellipses always start x squared, y squared. There's a plus between them. Tomorrow it's going to be a minus. Today it's plus. And they're equal to 1. We just have to choose where we put the a squared and the b squared to make it what we want. We want it to go horizontal. So what letter is the a going to go under? Yep. Yep, it's going to go under x. And the b squared goes under y. Yep. That's the first thing you should figure out. Your basic equation. Now, the equation only has a and b in it. You don't need c. But the problem is, they're going to give you c a lot of times in the problem. And they're not going to give you one of the a or b's. So we're going to have to figure it out. Do we have enough information to find a?
Yes.
Yeah, what's the definition for a? Yeah.
The center to vertex.
Distance from center to vertex. What's the distance from the center to the vertex?
4.
Okay, so we have A. Distance from the center to the minor axis. We don't know that. So we don't know B, but we need B. So we're going to have to figure B out. C. Center to focus. Yeah, we know that.
3.
The distance from the center to focus is 3. So what's the formula we can use? It's kind of like the Pythagorean theorem. It's not, but it looks kind of like that. Yep.
3 squared is equal to 4 squared
Say it again.
minus 3 squared is equal to 4 squared minus b squared.
Yeah, so we got to use that c squared equals a squared minus b squared. Yep. So c squared equals a squared minus b squared. And you'll never get a negative value for b. Never. A or b. Or c. They're all distances. All right. So 9 minus 16 is going to give me negative, yep, 7. Cancel the negative from each side. And really, you don't need b. You need b squared. That's what you really need for the formula. We can write down b. What is b in this case?
Square root of 7.
It is the square root of 7. But when we fill it into the formula, we're just going to square it. All right. So our final answer, x squared plus y squared equals 1. What's the denominator under x going to be?
A squared.
16. And the denominator under y?
9.
So, no, not 9.
7.
7. There's your ellipse. If you wanted to graph that, you'd have to get y by itself. Okay, we're not going to do that right now. That's it. Find an equation of the ellipse. Any question on that equation? All right, so that's one where I gave you some information. You gave me the equation. Let's try it the other way. I'm going to give you the equation. Now you tell me everything about it. No matter which way you're doing it, you really want to make this table first. A, B, C. Figure out your A, your B, and your C. Okay. What's A in this case?
5.
Yep. It's always the square root of the bigger number. That's A. What's B? Yep.
3.
3. The square root of the smaller number. Now, if they didn't ask you anything about the focus, you don't need C, but the focus is one thing I would ask you to discuss. So we need C. What's our formula that we use to find C again? Yep. A squared minus B squared. So C squared equals 25 minus 9. 25 minus 9 gives me 16.
4.
So C is 4. Yep. Okay, so things I would ask you about. Center. Foci. Yeah, the vertices. I always mess that up. C. Yes. Okay, so center, foci, vertices. I'd want to know the direction of the major axis. The two answers there would need to be horizontal or vertical. I think that's everything. Center, foci, yeah. Okay, where's the center here? Yep.
0, 0.
Right. When you start seeing like x minus h and y minus k in the top, then you know it's been shifted. Until then, it's 0, 0. Okay. What letter is going to help us to find... Actually, before we even do that, let's do the major axis. What direction does the major axis go? Yeah. It's horizontal because the bigger number is under the x. And wherever the bigger number is under, that tells you the direction. So horizontal. And that's important because now we know everything is left and right of the center. If the major axis was vertical, it would be up and down from the center. Okay, so left and right. What letter helps us to find the foci? Yep. C. How many units away from the center is each focus? 4 units. So we need 4 units left and 4 units right. What's 4 units left of center?
0, -4.
-4, 0.
-4, 0. And what's 4 units right of center? 4, 0. When it's at the center, you could do like the plus or minus 4, comma 0. When you shift it from the center, that might not work. What letter is going to help us with the vertices? Yep. A. How far away are the vertices from the center? 5 units, and they are 5 units left and right. So -5, 0, +5, 0. And that's everything I would want to know about the ellipse. What if I asked you though something like, how long is the major axis of this ellipse? 10. Major axis is 10 units long. What if I asked you, this one's a little trickier, how long the minor axis is?
9. 3.
6. B is the distance from the center to the minor axis. So you know from here to here is 3. So from here to here is 3. So the minor axis is 6. Major axis is 10. Yep.
Wouldn't it be like the distance of the, for the question before that, wouldn't that be like the distance of the vertices, not the distance of the major axis?
Same thing.
But
The vertices are the endpoints of the ellipse.
I would think that like the axis would be like infinite because it's like x and y axis, but then
Not the focal axis, the major axis.
Focal axis goes all the way.
Yeah. Right? So the focal axis, I said what's the distance of the focal axis, which I wouldn't. Well, that's infinitely long. But if I ask you for the distance of the major or minor axis, that's a finite number.
oh yeah.
Yeah. Okay, so we looked at a few horizontals. Let's do some other ones. Okay, so this one's pretty similar. except the difference now is the foci are still going to be C units away from the origin, but below and above. The vertices are going to be A units from the center, below and above, not left and right. Yep.
How do you find it, though? How do you find the foci?
The foci?
Yeah.
The foci, well, sometimes it's given to you in the problem, like that one. Listen. If it's given to you, well, you don't have to find it. If it's not, then I will give you the A and the B, and you'll plug them into that formula to find C.
What is B?
B is the distance from the center to the minor axis. So this is the case where the major axis is vertical. We already looked at the formula. Only difference is A and B switch places. Now the bigger letter is under the Y instead of the X. A is still bigger than B. B has to be bigger than 0. That's the same. And the relationship between A, B, and C is the same. And just kind of a little preview for tomorrow. Change that plus to a minus. Now you have a hyperbola. So it's a very, very small change. And in fact, A and C are going to have exactly the same meaning tomorrow as well. Center to vertex, center to focus. Okay. Does everyone have the information about the vertical case? All right, so let's try it. So this one says discuss. Well, is it set up in the right format to be able to discuss it?
No.
No. What's wrong with it? Yeah. It's not equal to 1. It's supposed to be equal to 1. So what we have to do is make it equal to 1. How would you do that? Yeah. Divide everything by 9. And this is going to make the A and the B a lot easier to see. Yep.
So would it be like a circle because the numbers are
This one's not going to be a circle because we're not going to have the same. It's not like we have 9x squared plus 9y squared equals 9. In that case, we would have had a circle. But we're going to have x squared, but we still need something in the bottom. So what could we leave in the bottom?
1.
Yep, 1 plus y squared over 9 equals 1. Okay, so let's make our table. All right, what's A?
1.
9.
Oh,
No,
3.
not 1, not 9.
3.
3.
Because it's 11.
So A is the square root of the bigger number. What's B?
Square root of 1.
Square root of the smaller number. Now they didn't give us C, but we need it because I'm going to ask you about the foci. Remember your formula? C squared equals A squared minus B squared.
Square root of 8.
C squared is 9. I'm sorry. A squared is 9. B squared is 1. 9 minus 1 is 8. So C is the square root of 8. Okay, center. Where's the center?
0, 0.
0, 0. Let's do the direction of the major axis. Yep, always want to do those two things first because everything else is based off those. So major axis is vertical. The vertices. How many units away from the center is each vertex? Yeah. Right, they're both 3 units away from the center, and they are above and below the center. So you need to go 3 up and 3 down from the center. So 0, -3, 0, +3. And the foci. How many units away from the center are the foci? Yeah? Square root of 8. That's exactly how we're going to write it. Square root of 8 units above and below. So 0, √8, 0, -√8. And that's everything they would want to know. Okay, any question on that one? Next one. Now you have to find the equation. I'm giving you a little bit of information. Again, my advice, if you don't want to do it this way, you don't have to, but I would figure out A, B, and C first. What, out of A, B, and C, can anybody tell me one of them based on what I gave you? Yeah?
C is 2.
How do you know C is 2?
Oh, okay.
Well, C is the distance from the focus to the what? Center, but I didn't give you the center.
C is 3 then, because it's the vertices of the ellipse, so that must be.
So C has to do with the foci.
C is 2 because one the focus is 0. We don't know both, so therefore.
Do you know both?
Can we infer that the base thing is 0, 0 for the what's it called?
The center?
The center, yeah.
No, you can't assume that the center is 0, 0, but you have enough information to determine that it is 0, 0. But that's what I'm kind of asking about. Yeah?
We know it's 0, 0 because so A is 6 because it's -3 and +3, so the distance, or I'm sorry, A is 3 because the distance between the vertices is 6, so you just divide that by 2. And
Yeah, if you divide, yeah, you could figure out, because you know you have a vertex at 0, 3, and you know you have a vertex at 0, -3. The definition of the center is it is the halfway point between the vertices. So the midpoint of those two is 0, 0. So yes, we do know the center is 0, 0. All right, so now, what do we think the focus is? Or what do we think C is? Okay.
Well, the other focus is going to be 0, -2.
Right, your focus would be 0, 2, and 0, -2 if they asked for it.
Yes.
So C would be 2. That's the distance between the center and the focus. How about A? How much? Yeah, that's the distance between the center and the vertex. But to write the equation, what letter are we missing that we need? B. And what's the connection between A, B, and C?
C squared equals A squared.
C squared equals A squared minus B squared. So 4 equals 9 minus B squared. We're going to get -5 equals -B squared. So that means B is
Square root of 5.
square root of 5. Now, that square root of 5 would only really be useful if I was going to graph it. What I really need for the formula is 5. I need B squared. But this square root of 5 tells me the distance from the center to the minor axis. So whatever the square root of 5 is, probably like 2.2, 2.3, that's the distance from the center, left and right. All right, so let's make our equation. Okay, what letter always comes first in the numerator? Yeah?
X squared.
For today. Okay, we got to get used to that one not being first tomorrow. But yeah, x squared, what letter always comes second? Y squared, and it's always equal to 1. And now to make it vertical, because we can see it is vertical, where is the bigger number going to go? Under x or under y? Yeah, it's going to go under y. And what's the number that you would put under y? 9. It's a squared. And what goes under x squared? 5. There you go. And that's the equation of the ellipse. Any question on that? All right, so the last thing before we shift it is looking at a circle. A circle is really just when you have the same number for A and B. So when the first denominator and the second denominator are the same. So since they're the same, we don't have to use 2 different letters. We could just call them both A. And that's because in a circle, even though this terminology isn't used in a circle, the distance from the center to the vertex and the center to the minor axis is the same. You don't really use that terminology with a circle, but that's what ends up happening. Now, because these 2 letters are the same in a circle, you usually see this letter, because they're the same, move to the other side. How would you move both these a squareds to the right side? Yeah.
Multiply both sides by a squared.
Yep.
Get rid of the a squareds on the left side, and it would put it on the right side.
Yep. So you'd have x squared plus y squared equals a squared. And what do you think this is in terms of a circle? Yeah. It's really the radius. That's why a lot of times you see it as x squared plus y squared equals r squared. So that's how you can get the equation of a circle from an ellipse. It's just an ellipse where both of those numbers are the same. And again, foci, you don't really talk about a focus in a circle either. Circles, they don't have a focus. The focus would really be the center. So any question on how a circle is just a special case of an ellipse? Yep.
When you're doing that, like for normal multiplication property, you're applying like a squared to each term. You're not doing like a big parenthesis for the left side the equal sign, the right side equal sign. You're multiplying a squared by each thing on the left side.
Yeah, it would be a big parenthesis, like a distributive property.
Well, like you're doing it to each thing, not
Yeah.
yeah.
Yep. So you multiply the whole left side and right side by a squared. And that's the only time that you see that ever move to the other side. You never see it move to the other side in an ellipse because they're different. But in a circle, you do because they're the same. All right, so now let's suppose that the center is shifted. We can use the exact same formulas. All we have to do is change it to have an x minus h and a y minus k. So when the major axis is horizontal, this is what you had before. You had x squared over a squared, y squared over b squared equals 1. Now, we're going to adjust for shifting left and right. Put a minus h with the x, put a minus k with the y. Everything else stays the same. A is bigger than b, b is bigger than 0. C squared still equals a squared minus b squared. And all the definitions of the letters are still the same. A is center to vertex, B is center to minor axis, C is center to focus. What do you think would change in this formula to make the major axis vertical and still applying shifts to it?
Are you still just switching a squared and b squared?
You're still just switching the a squared and the b squared. Yep. So this part of the formula never changes. The part that I just circled. Right? The only thing that can change between the top and the bottom is switching the a and the b. That's it. Okay, and that's on page 394 if you want to look the formulas up in the text. Everyone have the two formulas. All right. So now, regardless of what they're having you do, you give me the equation or you give me the information about the ellipse. Either way, you want to make this chart on the side. Okay, it has 5 letters you need to find. A, B, C, H, and K. Start with H and K. Up until now, the H and the K have always been what two numbers?
0.
They've always been 0, 0. Now they're not 0, 0. What's H going to be in this one? Yeah, 2. So H is the first number in the coordinate for the center. So H is 2. What's K going to be? Yep.
K is going to be -3.
Yep, K is -3. Based on that information, can anybody tell me anything else? Yeah. A would be 3. How come? Yeah, the distance between the center and the vertex is 3 units. Yep. If you have trouble seeing it without a sketch, you could always make a sketch. So the center is right 2, down 3. The vertex is right 5, down 3. Distance between the center and the vertex, 1, 2, 3 units. And there's also another vertex over here somewhere. Anything else that we know? Yeah.
The focus is 3, -3.
Mm-hmm.
So we can say that C is just 1.
C is 1. The distance from the center to the focus is 1.
We can figure out B based on A and C.
All right, how do we figure out B?
We use the same equation of C squared equals A squared minus B squared.
Okay, so C squared equals A squared minus B squared. There you go. So B squared is 8, which means B is the square root of 8. Again, we're not really going to be using the square root of 8 unless we were making a sketch. What's the other thing that we need to know? Because we've got all the numbers now, but we got to know something else, yeah? Right, we got to figure out, is it the horizontal formula or the vertical formula? Which one is this going to be? Yeah? Yeah, it's definitely the horizontal because your ellipse is right there. Okay, so horizontal formula. You're going to have x minus h squared. What's going to be in the parentheses of my second numerator? Yeah, that stays the same. Okay, what's it going to be equal to? Yeah, 1. Now we want it to go horizontal. So what letter are we going to put the bigger number? Or what letter are we going to put a squared under? Yep. A squared goes under x. Actually, you know what? I'll just write it first with letters. Now we'll fill it all in. Okay, so we're going to have x minus 2 squared. Okay, what's going to be in the denominator?
9.
9.
We don't have to worry about anything else other than that? Because it's a perfect number there.
Yep. What's going to be in the numerator for my next one? Yeah.
Y plus 3.
Yeah. We got to be careful because k is a negative, so it's going to be y minus minus 3. So y plus 3. Squared. Denominator there is going to be
8,
8.
because we have the square root 8. We can ignore the square and the square root,
Yep.
leaving 8.
So this is close to a circle. They're almost the same number. It's just going to be barely an ellipse, but it's still going to be a little bit of an ellipse. And last thing equals
1.
1. Right? And I could give you the same kind of question, except I start you off with this formula, and then you work backwards to figure out A, B, C, H, and K. And then you would tell me all this stuff. Okay, so you should be comfortable working either way. So that's an ellipse. Any questions on that? Okay. So let me double check. Okay, so 13 through 17, that's matching. Well, 13 through 16, that's matching. 21. Yeah, I think that's good. Okay, so that's the homework for tonight on 397. We will go over it tomorrow, and then we will finish conic sections tomorrow.